Alright folks, we've got another lesson today. Today we're going to talk about how to use the meter to measure voltage and current. Look, I really hope y'all are doing well. I appreciate y'all hanging in there with us. When this all gets over, imagine what a breeze it's going to be back in the classroom. So anyway, what I want to talk to you about is how to measure voltage and current. First one we're going to talk about is measuring voltage. And the first thing we need to do is connect the meter leads to the correct points on the meter itself. Them being color coded, it's pretty easy. The common hole, the one labeled COM, it's black and it's common to every type of voltage that this meter can measure. So we want to make sure that we connect the black lead into the black common hole. And since we're measuring voltage, we have this hole over here to the right of the meter that has the V on it. So that's the one that we want to connect the red lead to. So we connect the red lead to the V hole on the meter. So the next thing we need to do is we need to turn the meter dial to the V setting. So it being off, just turn it to the V setting, and you'll notice that next to the V setting there's a couple of lines. Well, this meter is capable of measuring DC voltages, like this course is centered around, and AC voltages. Now this is a pretty important point because it kind of has to do with safety and using the meter itself. So the straight line represents DC voltage. The little squiggly line represents AC voltage. Now when you first turn it on, it defaults to the DC setting. Now if you're doing measurements or in your car or checking your boat trailer lights or whatever you're doing, you're going to want it on the DC setting because all that's coming from the battery. Now here's the point that's important: when you turn it on, it goes straight to DC. So if you're doing something around the house, you want to check and see if a receptacle is powered, if you've got power up to the point in the light socket for your lamp, whatever. This is AC voltage. And if you leave the meter in DC and just try to connect it there to measure voltage, it's going to say 0 volts or there close to it. And the bad thing is that's not DC voltage, and you're not going to measure DC voltage. That's AC voltage. So you need to make sure that you press the select button to select AC voltage before you do anything around the house, because your house is AC. So a false reading in DC would make you think that the receptacle wasn't hot, and then you go in there and start working on it and come to find out it does have AC, and it'll shock the dog lip out of you. So make sure if you're working on your car or something like that, you leave it in DC. But if you're working around the house, checking stuff, you want to make sure you hit the select button to select AC, because that's what you're dealing with in your house, okay? So the next thing we need to do is we need to energize the circuit. Well, you got to apply power to a circuit before you can measure any voltage in, so you just got to turn it on. Next thing we do is we connect the meter probes to the points of interest, what we want to measure in the circuit itself. So the meter probes would go into the circuit, we would measure that voltage, and then simply we observe the reading on the meter display. That will give us our values of voltage. So folks, just to recap, we need to make sure that we put our meter leads in the meter properly. Black one in the common, the red one in the voltage hole. We need to turn the meter on to voltage, and in this case we're going to be dealing with DC, so we just leave it. However, if it's in AC, we can switch back to DC, and if it's in DC, we can switch back to the AC. But we're going to be using DC today, so really all we have to do is just turn the meter on. We're ready to go. After the meter's on, we've got to make sure that we have power to the circuit, turn the circuit or the device on, And then we simply place the meter leads at the points we want to measure the voltage and observe the reading in the display. Pretty simple, okay? So that's how you measure voltage. Now, let me put some notes on the board as far as measuring current, and we'll get started from there. So, okay, so go ahead and copy these. Pause and copy. All right, so now to measure current. Well, I can tell you this. First of all, you're going to have to pay attention when it comes to measuring current flow, because you can actually damage the meter or the circuit itself. So current is the actual flow. So we're going to have to get the flow to actually go through the meter itself. Well, think about it. How much resistance can a meter have when it measures current if I'm going to be putting the meter in the path the current's flowing in? Well, if the meter had any resistance, that added resistance to the path would actually affect the amount of current that I was trying to measure, and I'd get an inaccurate reading. So basically a meter, when measuring current, acts like a simple piece of wire. Has no resistance in it. So the deal is, if you connect this to a point where you have no resistance, in other words, if you try to measure the current across a power supply, the straight voltage potential, you have no resistance in the path with the meter. That will fry the meter, or at the very minimum blow the fuse. Yeah, in the meter mode, the meter does have a fuse in the path that if I exceed the recommendations or specifications of the meter itself, it will simply pop the fuse, protecting your meter. So at the very worst, you could end up with a blown fuse. So you really have to pay attention when you're measuring current flow. So first thing we have to do is we've got to connect the meter leads to the proper points on the meter. And over here on the left-hand side of the meter, we have a couple of A-holes. So obviously current measured in amps, we have an A identifying the current points. So there's two of them. There's a 10 amp hole and a milli and a microamp hole. Well, through our calculations and circuit analysis, what we've determined is how much current we're going to have, so that tells us which hole to put it in. Today we're going to be measuring current in the milliamp microamp range, so we want to make sure that we pull the meter lead out, the red one, and connect it into the red milli microamp hole. So now we got the meter leads connected properly. The next thing we have to do is we have to turn the meter to the amp setting. Well, you'll notice that we have a setting for milliamps and microamps and regular amps. So we're going to be dealing with milliamps, so we're going to turn it on to the milliamp setting. Now we're ready to measure current flow. So the next thing we do, and look, I drew an arrow up here, we need to open the path that current is to be measured in. I mean, think about it. If we're using well water and all of a sudden we're going to go to city water and they're going to put a water well, a water meter in there, well, first thing they're going to do is they're going to cut the pipe. And then in that pipe between where they've cut, they're going to put the inlet on the meter itself, and then the outlet will go to your house. So all the water that you're using has to flow through that meter so they can count it. Same principle holds true with measuring current using this meter. We have to break the path in order to reconnect the path with the meter leads themselves, so that the actual flow, the current, will flow through the meter to determine the amount measured. So next thing we have to do is open the path that the current is to be measured in. Next thing we want to do is we want to energize that circuit, because if we don't apply power, there's not going to be any current flow, right? So we got to turn it on. Next thing we do is we're going to use the meter probes, and we're going to connect one probe to the point that we disconnected and the other probe to the point we disconnected from. So if I've got a path, I'm going to have to disconnect that path and then reconnect that path with my meter leads. In other words, I'm going to stick one meter lead to the point that I separated and the other meter lead to the point that I separated from. Now this completes the path for current, and current will now come in, go through the meter, and then back into the path. That way we get the current that we're trying to measure to actually flow through the meter, and then we'll simply observe the amount of current flow in the display of the meter itself. Okay, so another recap, we're measuring current, so we've got to make sure our meter lead is plugged into the current hole. We turn our meter to the selection that we've determined that we're going to be measuring the range, and then we disconnect the path, we turn on power, and then reconnect the path with the meter leads so the current will actually flow through the meter. And then we look at the display, look at the value. Okay, so this actually concludes the first video. The next video is going to be the lab. You'll notice that there was a lab attached to the email I sent you to tell you about these videos. As you go through this next video, you want to make sure that you have that lab out, or at least a sheet of paper writing down the values that we come up with and the step numbers as we go through the lab itself. Okay? So, see y'all in a minute. We're going to get set up to do the lab, and then we'll go from there. Thanks, guys. Be right back.